as we study infinite limits more and more, it's important to identify some of the properties that will come into play when we start breaking functions into discrete pieces. And what you'll find is that limits obey kind of like algebraic properties, but really only in a very specific case. And that case is here. So if I have some sort of finite number c and finite number L, and I have two functions, f and g, where the limit as x approaches c of the f function is an infinite limit, and as it approaches c for the g function, you have a finite limit. So one of these is infinite and one of these is finite. If you have that case, then all the following situations hold. All three here. So the first one is that when you add those two things together, the limit of this comes out to be just the limit of whatever f is. And if you think about that, it makes total sense, because if f is shooting off to infinity, it's not like you could be like, oh, infinity, but minus 10. Well, that's still going to shoot off to infinity, right? Because no matter what, you're still just sort of dragging that anchor with you. And if it's plus 10, you're not going to get to infinity any faster. So the point really is that you have f of x plus or minus g of x. This g of x is basically irrelevant. It still shoots off to infinity. And an example of that is this. X approaches pi of 1 over sine squared x plus 15x. So in this case, direct substitution gets us 15 pi. That's a perfectly finite number. But 1 over sine squared x, well, that's going to shoot off to positive infinity. So since it shoots off to positive infinity, the answer is infinity. Over here we have the second property. If you multiply these together, this is where it gets kind of interesting. If you multiply those two limits together, or those two functions together, what you find is if the g function's limit is a positive number, it shoots to positive infinity. But if the g function is negative, it actually steers it down to negative infinity, which makes sense, right? You're either going where you're already going, or if it's negative, you're flipping down. So in the case that's positive negative, now you might ask yourself the question, what happens if the limit is actually 0 for g? And that one's a little trickier. That one comes later in the study of calculus. You have to do a little more cleverness to figure that out. So that's called an indeterminate case. But in this particular example, what we have two functions multiplying together. Now, as I plug in 5, I get the negative square root of 5, which is a perfectly fine finite limit, but I get secant squared of 5 pi over 2. Well, that ends up being like 1 over cosine squared 5 pi over 2, which ends up being 1 over 0. So this shoots off to infinity. So this shoots off to positive infinity, but this is less than 0. So that actually goes down to negative infinity. And finally, we have this case. And this is also a really interesting case, is that if I have the finite function on top and the infinite function on bottom, then the limit drives down to 0. And this doesn't matter if it's positive or negative infinity in this case. And you'll find that in general, this doesn't come up that often, or you kind of have to work at it to find those functions that for which it goes to a finite value and drives to 0. But as you move along in your study and we replace this finite number with like an infinity number, this comes up a lot. So this is sort of a contrived example where you have sine of x divided by 1 over x minus 3 squared. And so in that case, since this shoots off to infinity and this is finite, this goes to 0. And the reason why it's a little contrived is because with just a little bit of algebra, you could rewrite it as that, and by direct substitution. You don't need any sort of extra limit property. So it's not really that impressive to do that. But anyway, you'll find that most of the time when you have this, you can rewrite this. But when that starts to go to infinity, and then we'll get there when we get there, that it becomes much more interesting.